Welcome to the 7th episode of Distributed .NET Core course. It's Peter and
Derek.
And today we have a good news and a bad news. So
Yes.
maybe we'll start with that. So the good news is that we created a very simple solution based on .NET Core and the Blazor, which allows you to manage your services via a simple web UI. Basically start and kill your services, so you don't have to do it through the console.
Yeah, it's just a simple UI dashboard.
Yeah, you can find it here, DevMentors, Governor. So yeah, just another name for the manager, Thesaurus for the win.
Yep.
And you can simply start it by going to by cloning the repository, and you can either go to the src and governor.server and type .NET run, or you can just execute the start shell script, which does the same. So let's take a look. It will start this simple web UI at localhost 5020.
Yeah.
So it's going to be available here in a moment. And the overall solution is also quite simple. So on the server part, you can find the app settings here. And under app settings, you can define any apps. So for example, here you have the name, API, customer service, identity service, and so on. Then there is a path. So if our governor service is located in the same directory as our services are, we can just simply type this path. And you have to be aware that it has to go these three folders above, starting from server to src to root, and then
So basically you need to clone this repository on the same level as you keep your microservices.
Yeah,
then
change
no
the path.
change is required. Yeah.
Yeah, and here you just type the file name is what's the file that will be started as a process, argument, so .NET run. So it will basically go to this directory, execute .NET run on CSproj, and you will be able to navigate to your service. So let's see, it should be up and running right now. Okay, as you can see, it's created a UI for these services, and I can open this up. And here comes the Blazor.
Yeah.
Awesome
stuff.
So
forgive me for this UI.
Yeah. So I can, for example, click start on this API, and you can see here in the logs that it will create a new child process for the service, and the API will be available quite soon. Of course, it might take a little while, but
yeah, for now
it will be there.
It just the UI shows immediate result that is the service is actually running, but it takes some time.
So as you can see, it started here.
Yeah, it's just the MVP. So maybe we'll then add some subscription for the events that comes along with the process. So
here's our API. So we started the API, and basically it's all fine. It calls the internal API endpoint to check whether the services are up or down. So you can see whether they are running or stop, and you can either kill them or start them. But the only issue that we have for now is that when we actually when we click on this kill, and even though you can see that it killed the process, it's not down, and it's simply because there is this bug, right? Or sort of an issue.
I don't know whether this is a bug or
some issue.
Yeah, but basically underneath, as you saw, what happens is basically we call the .NET run. So we call the CLI to run the microservice for us. And what it does, it actually creates two processes. So as you see in this case, we have the one separate process from the .NET run, and underneath we have additional child process that's you could say on the Linux when you type PS3 or something. So this creates this additional child process that actually does .NET exec, and we don't have an access for this child process. We only have a process ID of the parent one, and this is not enough for actually killing the particular service. And I found a workaround for this, or maybe not workaround, but this working solution, but it is Windows specific, and we kind of need to came up with with some more universal idea than just Windows specific. So
So
if you know how to kill a process by given ID and all the children processes, you can contribute to this project, and maybe
yeah.
you'll come up with something more clever than we did. Because for now we we need to take a look at this.
Yeah, but this is once it's done, this will be much simpler to actually test your services because you can just
Yeah.
click start and kill, and you don't have to type it into your terminal.
Yes.
So that was the good news and the bad news. So now let's get into our today's topic. And one of our goals is to make this video no longer than the previous one.
Yeah, we'll see.
Okay, so let me close this one. And today we're gonna talk about the thing that's been actually there since first or actually second episode, and I think it's called collation context. And you can find collation context in each one of the handler, right?
I think that but I think that we should start with more general briefing. I mean, I would start personally with the thing that actually we followed for all these episodes, which is the CQRS.
Okay.
And as you probably remember, the CQRS, when you want to be exact with this principle, then writing to your application means that you can mutate the state, you can persist some data to your databases or play with your domain objects, and that is totally fine. But as you see in this example that actually were closed, can you get back to...
Okay.
This as you see, because this is the command handler and we do this interaction with our with our domain, then we return the generic task with no result. We cannot say whether this action succeeded or not, because as you see, we have this very simple validation that we added. And as you see, for now, if the customer is null, we the only thing we do is logging, and then we just return. We are quitting from this method. And as you probably guess, we would like to inform end user somehow that his operation failed. And it would be also cool to give him a reason to display this on the UI or something. So that's the I would say that the CQRS implies this issue, because in a typical scenario, or when you have the when you don't follow this principle, it's kinda easy, because we could return some boolean or result saying that okay, this just simply doesn't work. And of course, there is one more thing, that we have this asynchronous communication between API and the particular microservice, and we just use the publish subscribe messaging, know the request response. So even though we could have some result returned from the handler, it would be impossible to return this through the QE. So we have these two issues, and now we need to solve it.
Yeah, and like we said quite some time ago, with asynchronicity, all the fun starts, and also all of the issues arise.
Yep.
So yeah, we have two issues there. The first one is how can we let our end users know that something either succeeded or not. For now, we are only able to say that something succeeded simply because we published this discount created or some other successful event type, right, to the bus, and then the user could just get the discounts by calling this endpoint, and maybe they were actually in the database, but maybe they weren't. Maybe there was something wrong, right? So even if the user was maybe to create a product that already exists, he couldn't really know whether the operation succeeded or not, simply because he would have to fetch data from database and see, oh, there is no data. What happened, right? So how can we let the end user know what's going on? And the other thing that's actually part of this issue is that even if I will how can I let my end user know? How can I know which user originated the request, right? Because once you create a request from your API, for example, let's say products controller, and you send a post, create a product, then how can you know that exactly this user and this request started here is the origin of the event, for example, product created or product updated, that will be published later on, right?
Yes.
So these
Yeah.
are two things.
Yeah, you need to
And
remember that having this domain distributed into several different microservices implies this, that for some actions that starts from the UI, you might go through several different microservices to actually complete some. In this case, I would say that some kind of a use case, right? So one business transaction might go across several microservices, and you need to keep tracking this operation. We need to kind of track this and know that, okay, so we have this event, and that was raised by another event, which was raised by a command, and the command was posted by this user. We need to kind of keep track of this to let the user know that something happens with his particular message. So that is it's very important for this.
yeah, and even for such simple use cases like command event, you get this issue immediately because you can't match who created, who, like where this event came from, who originated this event, which command or which user. So this is what I said at the beginning. This is where this thing called correlation context comes in handy, and the idea behind correlation context is quite simple. So correlation context is your context that you can pass as part of your message. And if you're wondering how is it being passed, if it's, for example, for RabbitMQ, you can pass it via headers, but maybe we'll show the code later on.
Yeah.
And if you take a look at this interface, it's very simple, and you can put here anything you want. So this is just some of our properties that we decided that might make sense here, but really the only thing that you need most of the time is the ID, this correlation context ID. Okay, so if you take a look at our API, let's say our discount controller or any other post, put, and delete method, and if you come down to the send async, you can see here that we have this get context, and what it does, it just creates a new context. So we have this simple extension method here and a constructor, so it will have this data set, and it passes the new ID, right? So create first parameter ID. So when you send a request to the API, and it's this sort of command request, which is not a query, it will get a new ID, and this will be our correlation ID. Yeah, it's called correlation ID, and we just decided to put it into this class, this interface, because we wanted to have more properties here, but we could be just fine only with having a single ID property and nothing else. So we have this correlation ID, and then let's say we have this discounts, create discount handler.
Oh wait, maybe can you just get back to the because you showed the get context, and we need to kind of actually show how it's published. As you see, we have this send async, and this gets two arguments. We have this command and a context that is actually then, as you see.
Yeah, so there is a context, and you can pass this, for example, for raw rabbit library, and we have this sound context, use message context, and you can put there any class, any interface.
Yeah, use message context is provided by raw rabbit. One of the package that actually lives there.
Yeah, and it will be serialized using the headers in the RabbitMQ.
Yeah, so just to make it clear, correlation context is nothing more but the metadata that comes with the message. But what is important that we will I think that there's a word like for this, like flowing, like this message will flow through the together with all messages that will be actually part of the, let's call this business transaction, even though it's just a command and the event that corresponds to this. So we will not mutate this correlation context. As you see, this is immutable message. We just want to create this at the beginning, very beginning, inside API gateway, and then just let it go with the messages that will actually be involved in the particular business transactions.
Yeah, so you publish it here for the first time, you create it here down below with this unique collation ID, and then later on through all of these message handlers, you get this as the second parameter, whether it's an event handler or comment handler, you get this here, and then in order to pass it further, you just pass it again through this publish async or send async methods as a second parameter. And this is how you pass the same context from the API, which has the same ID and the same metadata that was assigned in the first place. So this is how we can resolve this issue of not knowing who originated the first request. And this is where this context comes in handy.
This basically works the same way like when you order some parcel from the internet and you get this delivery number that you can actually put in some website to track your delivery. So this works the same way, but in the microservices. We just want keep this in this correlation context object, and that's basically this.
Okay, so maybe let's get back to our previous problem. Once we know how to deal with this, with passing this the same context over and over again. So here we have this happy path, discount created, and here we have this path which is not really happy because our customer doesn't exist and we cannot create a discount. So we need to let the end user know that we couldn't create it and maybe send him a reason why you couldn't do it, some error code or whatever makes sense to you. So what I can do here, I could probably throw an exception, but it's not really helpful because the exception will be thrown and it will be handled internally by the service. So that end user would have to somehow get this exception sent to him, we'll have to send this exception to him right back, or the end user would have to call some errors or exception service and see, oh, there is an exception, what happened, right? So we don't want to do it. We just want to send him the response as we would send from our API, like here, and you could say, all right, so my post failed, and here is the 400 bad request status code with the errors collection and with error codes. We can do it here, but we could try to do it in a little bit different way, and we could do it again with the events. Yeah. So here we have our happy event, discount created, and now let's create an event.
Sad event.
Sorry? Yeah, that's sad.
Yeah, that's
sad
not
event.
very happy event.
Not so happy event, exactly. So we can call it something like create discount failed or anything similar, which means there was a failure. And especially for this scenario, we created an interface called iRejectedEvent. So as you can see, this is an I event, and we just defined this iRejectedEvent, and it has two additional properties. The reason, so you can put here an exception message if you have some, save exception messages, or some other description of your issue, error code, and you can also put here some other properties. Yeah. So we will create a new rejected event for our create discount. So let's get back into our discount service, and here under the messages directory, let's create a new class. And let's see if my rider doesn't stack.
Hopefully.
Doesn't get stuck. So I will just call it create discount rejected, like this. Well, okay. So right now,
I was afraid.
that was close one, close call. All right, so it will implement this iRejected event, and it requires to just add these two properties here. And yeah, that could be pretty much it. But of course, we can pass here even more data. So besides this reason and code, maybe I could also pass here the customer ID, like GUID customer ID, or the discount code, or whatever that is, right? So feel free to put here anything you want. And just a getter. And let's do the constructor.
Oh, that's awesome. Awesome snippet.
That's my favorite snippet.
Yeah.
At least for now. And mark it as a JSON constructor. And this is our event. Now we can get back to our handler, and let's publish this event. quite similar stuff as down here below. So we just call our bus publisher, publish async, and then new, create discount rejected. We'll pass our customer ID. Then we can pass a reason. So let's say we can just copy the same message, or maybe there will be some exceptions, so you could get the exception message. And let's pass here an error code. So maybe I will say customer not found. Like the idea behind the error code is that on your, let's say, web app, you can take this code, look for it in your dictionary, and then render, a meaningful description for this error code. So this is why we added these error codes here. It could be enums, numbers.
Yeah, because sometimes when your website supports more than one language, it is very helpful to use this. Yeah. So we have this additional parameter, as you see, this is the context, and we don't create a new context for every publishing. We just use the same one. So as we said, we just keep it together with our messages.
Yeah. So now when we start the app, okay, we can publish this message once our customer doesn't exist. But again, we have no idea what happened because, well, it will be just a message that will be sent to our RabbitMQ message bus, but the end user still doesn't know what happened and why it happened.
Yeah, okay? Unless he knows RabbitMQ. So maybe.
Yeah, and unless we give him an access to to our RabbitMQ, which we probably don't want to do it, at least in the production mode. So what we can do about it? Well, if we take a look at our send async in our API gateway, let's take a look. Discount controller, send async for a post, and here let's see, it returns the TO2 accepted status code, but it also returns this magic header. So into our response headers, we are adding this operation. We just call it operation. It's not like a standard. We just figured it on our own, and we have this operation header. And I also had once a good discussion that it turns out that X is not needed for the custom headers, as the specification says. So you could just omit this. So we have this X operation header, okay, and we are adding it here down below. Before we return our accepted response. And in this header, we are returning this operation/context ID. So as you can see, we are returning here some sort of endpoint. It could be relative, it's a relative endpoint, but it could be, of course, absolute endpoint, like in location header, which points to operations/ and our collation context ID. And of course, it could be some other ID, but we just decided let's take our collation context ID because it will be the same for all of the requests, all of this message chain, and there could be a lot of messages. So we are interested what happened with our operation, okay? And we could probably get some details about what's going on with our current request. But before we can actually ask this service, and the service that does the processing is called operation service, and we can ask him to return this data for us about this operation. So whatever is happening here, we define it as operation, or it could be a request, right? You can treat it as a request that is being processed and a request status. We just name it operation. And before we can, start using this operation for our discount, we need to add it into this operation service. Because for now it's just a message, and this message will not be stored anywhere, especially in an operation service, because it has no idea, at least for now, that there is a new event, right? So we have to define an event for him of this type.
Yeah, basically, what it does, this whole operation service, what it does is basically it subscribes to all messages that we have. At least the defined messages. I would put it this way. So we have this. I think that we have. Yeah, as you see, we have this subscribe to all commands and to all events. Oh, okay. So basically, we have this subscription for everything, and once we publish a command or event, we create this operation domain object, which has the internal status. So we can say that this is the operation and the status is like pending or rejected or succeeded. So basically, as you see, maybe we can say, yeah, so this is the DTO for this operation. So as you see, we have this ID of the operation, which is nothing
Collation
more
context.
but the ID of the correlation context. We have this user ID that actually posts the first command, the name and the other stuff, and the state, as you see. So in this case, it might be like successful or rejected or something. So the flow is very simple. So once we publish the command, first the discounts will actually get this command and that will start to process this. But also the operation will subscribe to this message and will create a corresponding operation object that will represent this the operation. And once we publish an event, it might be either successful, so I event, or rejected, so I rejected event. We will simply get the operation object from the MongoDB, from some data access layer. We will update its state. So we'll say, okay, so that was the pending operation and now it is like rejected or successful. So that's basically what it does.
Yeah. So if you don't have the latest repositories, just make sure that you will pull the latest changes from operations and SignalR service and also the command package. Recently, we made these things a little bit simpler. So here within this generic event handler, we are listening down below to either rejected events, so we know that something failed, and also for just generic events, meaning that there was something successful. And this is only scenario for this typical simple use case command event, which is all. We'll talk about this scenario probably in the next episode, but for now we'll focus only on this scenario. So you send a command, the API sends a command, for example, create product, and then either the product gets created, which is the successful event, and it gets here, or the product gets, doesn't get created, and the product service just publishes create product rejected event, and it gets here.
Okay.
And it just sets this.
So now this is the version without the first step. So
yeah, this is without the command, just this successful use case, because with these commands there was sometimes this race condition, and because sometimes you could have the event before the command and so on. So I just made it a little bit simpler for now. So we only listen to these events, but of course you can extend it with commands and also subscribe to these commands as your first event. So now we have our rejected event defined. We need to add this to this operation service. And I want you to keep in mind one thing, because here we decided that, okay, let's just put here all of our messages. But sometimes you don't need to have this sort of, very responsive, subscription where your end user knows right away what's happening with his request. Because sometimes, let's say when you create an order, the only thing that you need to get is maybe an email message in a minute saying, oh, your order was completed, or there was an error, your order was rejected. So maybe this is how you can handle this this whole flow, and how you can let your end user know that something failed or not, maybe by sending him an email message or an SMS or whatever it is. But if you want to have something very responsive and you want to know what's going on with requests
sort of real time, then you need to. I would say that this also depends on the domain of your application, because if your interaction with the UI and the messages that comes from the backend are very important, then you should really take this topic seriously and make sure that all your responses will come as soon as possible using the techniques that we'll present you in a couple of minutes. But if you have that your domain is it's not that focused on actually writing more than reading. I would say that the example might be some social media or like Reddit or something that, you can upvote something, but if something will fail and you will not upvote the post, then this is not a big issue for the Reddit as a website, right? For Reddit, I would say the worst thing is when you can't actually read something, right? When you can't access some articles. So in this case, it's not like all messages needs to be keep tracking in the real time.
Only some subset that really matters
Yeah.
to you, and you want it to be like being tracked real time. Because you have to keep in mind that again, it's another service, so it can be another, some point of failure, and you have to maintain the service. So again, remember, the less code, the better.
Yes.
So let's define here our message. So under messages, I will create a new subdirectory, and I can just call it discounts. And here I can, just take this create discount rejected and just add this event. So just like we have our messages for the remaining services defined, events, and let's put here the create discount rejected. And in this operation service, the only thing I really care about is the actual the context, collation context, which is being passed through the handlers, and also the either event or rejected event, and these two fields, these two properties.
Yeah.
So I don't really care about customer ID. I don't really care about product names, price, anything like that. So I could basically copy just this part without this customer ID because I don't care about it at all. Okay, like this, remove this field. And now we are good to go. Oh, and a constructor. Okay, of course. Okay, and now we are good to go because down below here, as Darek said, through this reflection, we'll subscribe to all of these messages at the beginning, and that are type of either iEvent or iCommand, and of course of type iRejected event, because iRejected event extends the iEvent interface. So right now, we should be good to go, I think, and we can give a try, right?
Yep.
All right, so let's see. And what do we need to start? So we'll start the API as a gateway. So let's get into our API.
I think, dude, we should use the dashboard for this. Yeah, because this works.
Oh, okay.
Starting the services actually works.
Let's see. Yeah, I know starting works, but let's hope it it will not break anything.
This is the moment of truth for this.
Yeah. Okay. So let's get here. And yeah, even if it doesn't work, we can at least show which services we want to start. So I want to start the API for sure as a gateway. And then we don't need to start the customers. We can start the customers. It will be for the happy path. So let's start the customers. Let's see if it should start quite soon. Okay. So let's start the customers now. API is up and running. Right now we are starting customers. Yeah, in the next version we'll have some progress bar here.
Yeah, we just need to subscribe to the event that comes with the process object. I think that there's definitely exited for this. I'm not sure whether this is something like started, hopefully.
It seems that... Oh, my Redis is down somehow. Okay, it's not down.
Docker PS.
Yeah, okay. So API, customers, two services up and running. Identity, correct.
Yep. We don't need notifications, I believe.
No, we need operations.
Yeah.
And we need discounts. We don't have discounts here, so we'll just start them through the console because I don't want to restart this and update my app settings. So
I think that we can start the discounts from the rider because we could debug them.
yeah, and yeah. So the last one was operations. Okay, let's see. Okay. All right. So let's start our discount service. And in my debug, let's choose the discounts.
Yeah.
Okay. And let's start it. And let's put the breakpoint into our handler, which is here. Okay, here and also here for both paths.
Okay.
Let's wait for our operations.
Do you have any customer in the Mongo?
No. My DB is clear because I always restart everything for Docker Compose. So let's start maybe with the happy path. Okay. Okay, let's go to our API and to the rest. And yeah, let's just create. We don't care about products for now, so we can skip this part. I only want to create a new user. So I want to sign up. Let me just check whether we have our discounts handler without any specific authorization. I think it should be plain and simple. Let's see.
I think you have allow anonymous on the hell.
Yeah. Let's see. Okay. All right. So we have a new user, and we can just sign in. I'll get the token. Okay, and now let's try to create a new customer. And let's see. I will click send request. And even here you can find there is this URL operations, and here's our collation ID. So what I can do now, I should be able either to call it through my operation service directly, like this. Okay, let's see.
404. Is this?
Yeah. Let's. I'm not sure if there was a customer created event. Let's see. Okay. Let's see if the customer is here, just to be sure.
Yeah.
Okay, he's here.
Maybe the endpoint was simply bad.
Could be, or let's see. Operations. It should be fine. Operations controller. Yeah, the only issue is that it's a little bit more. There are some troubles if I want to do if I want to scroll the logs.
Oh
so
yeah.
There was sign up.
Yeah.
Identity. Customers. Post. Operations. Okay, and there. All right, let's see.
Yeah, this will be much easier to trace once we actually introduce tracing.
So yeah, that's
rather than scrolling through the logs.
Yeah,
but
that's
maybe just go to the operations.
Yeah, or I know which could be the issue. It could be that our Redis doesn't work, or it works. Let's see if there's data here. Okay, maybe maybe it didn't store the data. It could be that when operation service started, maybe
Redis was down or something.
Maybe it had some issue to talk to
so
Redis.
Maybe restart this.
Yeah, but I have to.
But
we have to stop this, right?
Yeah, but
this one. Or okay, let's do it smart way. I will just kill my operation service.
Do you know
let's
the?
See. Oh, not this one. ps.net. It's going to work. No.
But you don't know the process ID of this. So
yeah.
you can choose from 6 or something.
No. Okay. here it comes.
Okay.
Here it comes. I'll get to him. I just need to make it a little bit smaller, at least for now. Okay, one more time.
Yeah.
Operations.
So we're looking for operations.
This one, 4, 5, 3, 6.
That was smart.
And I can just kill force kill 4, 5, 3, 6 like this. Okay, it should be down. Let's see. Yeah, it's down.
Yeah, looked like a pro in a terminal. Yeah.
Yeah. All right. So let's start our operations here, like this.
Okay.
And let's try. So our operations, src, it has this operations controller, and it should be able to
maybe
return
clear
the
the
data.
customers for this identity in a moment.
Oh yeah, sure, I will. But I'm pretty sure that it could be something related to Redis, because it talks to Redis to get the data, so it could be some issue. All right, so let's drop the base. And I'll also remove this one from here. Okay. All right, it's up. A lot of subscriptions to the messages, you can see.
Yeah.
Or maybe something failed during this initialization. I'm not sure. All right, so one more try. Create a new customer again. Okay. Okay, so it handled the message, our operation service, and now let's only take a look at our Redis. So in Redis CLI, I should be able to. All right, it's not here somehow. But let's take a look. We have the operation ID, this one, and it should work.
That is weird.
Somehow it didn't.
Where's the controller of this operation?
So operation storage set, and it should store the message. Okay, maybe let's just run in debug mode. Maybe there is some bug.
Yeah.
It will be the best way, I guess. Okay. It could be something with Redis, but yeah, let's just be certain. So let's just stop our discounts for now, and let's debug the operations. I know what's the issue. And the issue is quite obvious, I guess. So I'm afraid that I forgot to put the message namespace to our message. Yeah, this is. I think that's it.
But this is a create
but
discount
this is for
region.
discounts. All right. So it's not an issue. But okay, let's yeah. But also we would be surprised why the next one didn't work. So. All right, let's put a breakpoint also here and here. I mean, also put it here.
You will see. Maybe there's some issue with the connection to Redis or something.
Yeah, or maybe there is some issue in this part. Maybe it takes this message somehow. Let's see. It shouldn't, but
I think it should. We have one saga that actually corresponds to this.
Yeah, it could be this one. It could be the issue with this one.
I'm pretty, you can put the breakpoint, inside.
Yeah, and should we have here return? I'm not sure anymore.
I don't think so, but
there shouldn't be a return, right?
Yeah.
Okay, maybe those.
Because processing by the saga is the one thing, but
yeah, okay, all right, that makes sense. So, but yeah, let's debug it anyways. Maybe I did something that wasn't meant to be here. All right. Collections. Refresh.
Okay. Yeah, this is fun.
Yep. Okay.
So let's try with this.
Let's try with the debugger.
Creating.
Yeah, so let's try, right? Create customer. And we should get this message here. All right, so handle. All right, we don't care about this one. And we should get the event about customer being created. Let's see.
Yeah.
Hopefully. As long as it was created. A lot of logs. Yeah, it's missing our logs. And
Well,
we have some
null object. I see. A
yeah.
subscriber.
Maybe did I edit some typo? But I guess I didn't. Customers.
But a typo in what?
No, it's fine.
Yeah. So we have this null reference exception, and this comes from the from the handler create customer. That is fun. Okay.
Oh, yeah, I know which one. I removed the customer, and the customer is related to the user identity. Yeah, that was the issue. Okay. Yeah, because user is a customer. All right.
That was the issue. Jesus.
Yeah.
Okay.
Okay, and it could be also the issue of our operations will be returned, but yeah. Finally, this is the debugging. Everyone loves it.
Yeah.
All right, so the identity service published this event, set async, and yeah, let's only take a look if it works correctly. And yeah, right now we should be able to actually take a look at our Redis. Let's see, we have the data here or not. Yeah, finally it works. So we have some data here. All right, now let's create a new customer, and maybe I will start our discount service
But
just
was
here.
it the empty GUID?
Yeah, because for the identity, we don't really pass anywhere this context. It has no context. It's a separate microservice that is exposed. Okay. Right, everything is synchronous here. Yeah. All right, so maybe I'll just start our discounts here. All right. Okay, customers. Final try. Accepted. And we can get our operations. AT. And yeah, let's wait. Let's take a look. Okay. I think that something is wrong with our with our customer service. Or not.
It does not create it.
Okay, it's here. Okay, maybe let me just ensure that I have the correct access token. And let's make let's see if our customer, okay, it's null. All right, one more. Sorry, not the products. The customers. Okay, finally we are here. Maybe I had a bad access token. There was some mismatch.
Yeah, maybe this.
All right, so we are getting here into our events. But before I click F5, let me take these operations ID, and let's see. I can call keys again. Okay, it's not. Oh, so yeah, it's not here yet because it's an event. So F5. All right, we are not getting here for now, and the return wasn't needed here. That's correct. So I have to publish the changes. Right now we will store our state, which is completed because it was a simple use case. Just create a customer and nothing else. So yeah, here is our key, and finally I can grab my operation DTO, which looks like this. As you can see, yeah, finally, our collation context ID, the user ID, the name of the command that originated the request, state, for example, the resource, the endpoint where we can get our customers from, code reason empty because there was no exception.
Yes.
So maybe let's try to create a customer again, and it should fail now. Now let's see. So one more time, create a customer. And yeah, as you can see, we have our rejected event right now with this reason. The customer account was already created for user and some code. So F5 again, we are getting into this rejected event. Okay, saving the state.
Yeah, I will save this to Redis.
I will just remove these breakpoints here. And again, we have our data in Redis.
Can you get this
from Redis?
No, that was the first.
This one?
Yeah.
Okay, I think it was hgets and data. Yeah, I don't remember the exact.
Yeah, so just put it into the browser.
Yeah, I think it was hashget, the key, and there was a field called data or something. All right, but let's just put it here. So, no, not the data. Again, our endpoint, and we can of course call it from our API, which is desired by the end user, because our operation service it's running internally. So for the API gateway, I will get my data about operation. As you can see, create customer, state rejected, and here is my code, customer already completed, and customer was already created for user, blah, 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 blah. Right, so here is our rejected. So this is how we can let the end user know there's something wrong. And maybe this last try, and maybe we'll just do it here. Let's say try to create our discount, right? Maybe without the debugging. So
yes, we'll simply do this. We'll see whether our validation actually works.
Okay.
And I think that we actually verified this, but we didn't see it coming in the web browser. So
okay, all right. So as you can see, even though our discount service was down, because some people ask, what if my service is down? Sometimes on forums or on Gitter. Well, if you have the queue and your service is up and running again, it will get the messages. And so our discount service has this customer. It created this customer, and everything is fine, right? So no worries if your service is down. It's normal behavior. Just make sure that your RabbitMQ is up and your queue is alive.
I wouldn't say it's normal behavior, but you
should not be afraid. Yeah, but you shouldn't be afraid. Yeah, you shouldn't be afraid. Okay. All right. So right now I want to create a new discount. It's down below here, and this is this post. Our customer ID is something fake. Let's just call it. And we have our operations ID. And take a look, event, and it's a create discount rejected, right? Cool. So we should get into this part, and we can grab our operation ID, and let's put it here. And yeah, it's working. So it's quite cool. Our user ID is of course null because there was no authentication required. So do it empty here or null if you want. And this is how we can deal with this stuff, by having some other type of service that subscribes to either all of the messages or some subset of messages that it's interested in, and it will somehow internally track the state, maybe simply by saying that it completed or failed or something else happened. And this is for this simple use case, create comment event.
Yeah, but for more complex, for the first if, in this case, we will get in the next episode, because this is more fun, I would say, even more fun.
Yeah, this is for now. It was merely any fun.
Believe us, that was the happy path. I would say in this case. But we still have, of course. So now we have this, as Piotr presented to you. We have this endpoint, both inside this in the API gateway and which actually calls the internal API of the operations service. But we need to kind of deal with it on the UI. And of course, some say that you could do some long polling and just set the timer in the JavaScript and once a few seconds just ask about this operation status. And once it actually returns something from the API, we could create some toast or some pop-up or alert, whatever you want to do, and inform the end user that your operations succeeded or was rejected. But of course, I mean, we don't claim that long polling sucks, but it sucks actually. So for most of okay, but we just want to do this more pro and do this in a, I would say, more real-time way. So we are going to extend this functionality by adding one more microservice that you probably...
Yes, new microservice.
Yeah, for this simple solution, yeah, we'll use the SignalR. So if you don't know this, the SignalR is very cool library that actually allows you to create, allows you to push messages from the server to the client using the WebSockets. And of course, if your web browser does not support WebSockets, then it just fakes it using some fallbacks. But by default, this tries to push your messages using the WebSockets. So this is the communication from the server to the client. So there's no need for the client to ask the server whether some operation succeeded or not. We just subscribe to the particular channel and wait for the notification that comes from the server.
Yeah.
So this is way more. I would say, we just create less round trips to each other.
Exactly. If you can push the data, push from the server using WebSockets on the server side push thingy, is usually better because you push it when you push data where actually data gets updated. So when things happening, you know about, and you push it at this exact time.
Yeah.
And you reduce the traffic, reduce the latency. So just update your end user about things that are going on with your request or with your data, and you don't expect from your end user to just call you for data at all times, by long polling.
Yeah.
And everything starts here in our rejected event switch switch case, or here in this event switch case. We have this operation publisher either publish rejected or publish completed. So if you take a look here, very simple. We're basically publishing to this to the message bus our custom message, custom event called either operation pending if this is some long-running process, operation completed, or operation rejected. So everything starts in our operation service, which publishes the message to the message bus, and then we have the SignalR, which is another service, and it subscribes only, at least in our scenario, to these three types of messages, right? Because it wants to know what's going on with our request. So it subscribes to these three messages being sent by the operation service. And if you take a look at the handlers, we have this single handler for all of these events. And down below, it only listens to these events, and then it invokes one of the three available methods, which is all about sending the data to the end user using WebSockets. So if you take a look at this hub service basically takes this event and publishes to the user, right? So it takes the user ID, which is part of our operation pending event. Of course, we could also pass here the collation context and grab the collation ID or the user ID from the context, but we don't have to do it. We can just use the event here, which also contains the user ID. But the collation context will be also fine, and it just publishes the new message to the end user with this the data like ID, name, resource, whatever you want.
If you're familiar with the SignalR, this is the common thing that you actually do with this hub context.
Yeah,
so
clients, group, send async. And for each user, we create a group. So we create a unique group based on the user ID. So if you have like multiple devices, you will get the data on all of your devices, right? That's how you can do with this. All right, so let's start our SignalR service.
Yeah.
And yeah, let's just start it here to see the logs. And just to see how it's working, we can browse a very, very simple website. So, okay. I can go to localhost 5007. And here we have our www root and the directory called SignalR. So I can go to /SignalR index.html. And here is my awesome UI for the SignalR. So you can see it was trying to connect to our DShop app, but it got disconnected because there was an invalid token. So I can open this app.js. SignalR.js is the library for the JavaScript. App.js is our application JavaScript.
Yeah.
Yeah. Sorry, the writer is not aware about the ECMAScript latest version and some of these keywords. So this is why you can see there are some warnings. So the only thing I need to do is to just update my access token, because when I initialize the connection to the hub, I basically pass here the token with query string and create a group for the user. So this is this very simple scenario here. So let me take my token from here and just pass it to my app. And okay, here. All right, save.
This is great that you actually created the UI for these messages, but you forgot to create the input for the token.
Yeah, I was thinking about it, but it was it was late hour and
it was too
and just okay, maybe my token got expired already. I'm not sure, but let's see.
Maybe ask for a new one.
Yeah, I think I will. Okay, maybe there was some typo. So I'm connected, right? So here I started the connection, invoked the initialize sync on my hub, and I got connected. Previously I got disconnected. As you can see, I'm subscribing, I'm listening to these 3 messages: operation pending, completed, and rejected, that will be sent to me through the WebSockets. So let's try to invoke here the again the create customer.
Yeah.
Like this. So post and wait a moment. Oh, operation rejected, right? I got an error. My customer was already completed. All right. So maybe let's try to create a discount. One request. And again, through the WebSockets, I'm getting the data that something. Oh, sorry. I wouldn't get data for this one because we don't have the authentication here. This one will not work. But
so maybe create a product. You need to be an administrator, I think.
Yeah. So maybe let's try to do something that will succeed. I will create a new administrator account. I will grab the admin token, and I will also pass the admin token to the app.
Yeah.
Which is here. Okay. Like this. Refresh the page, and let's try to create a new product. I will just need to start the product service first. Let's say the products. Okay. And yeah, we are connected. So I will try to create a new product, which is here.
Yep.
Okay. Service is up and running. Let's try. I will send a request. Here is my operation. I can always use this as a fallback, right? So the only reason we have this API is that if you can't use WebSockets, then you can just call it using get, and this is a fallback. All right, completed, right? And my internal object with this data. Let's try to create the same product again. It will fail. Now I'll create a new product with valid name again. So as you can see, everything works as expected. And this is how you can deal with this, real-time updates. If you want to do this tracking of your messages in a real time and update the end user what's going on, you can do it like this using WebSockets, using the service that subscribes to those messages, and by implementing your own tracing of the messages.
Of course, this is
And
not.
yep.
I wouldn't say this is. It's kind of more complicated on a front end to actually keep tracking of this WebSocket channels and make sure that you're actually subscribed, because this is now you're taking the responsibility of message delivering from the server to the client, because we actually assuming that we actually publish this this operation update using the WebSockets, you need to be sure that your client actually subscribe to this, and because without this we just cannot inform the end user that we updated this operation.
And when you're using SignalR, for example, you have to remember about thing called backplane, right?
Yeah.
Which is here, and you can add it through the builder of services. Because once you run your SignalR service as more of a single instance, let's say 2 or 10 instances, and the request A and you have the user which is connected to the instance A, you want to ensure that, for example, for your load balancer, which which directs how the traffic goes, that you are always connected to the same instance, and that this communication doesn't get mixed up between different instances. So you can use this backplane, which by default uses Redis and is probably the best solution, I think.
Yes.
And last thing, as you can see, we decided to use our token to connect to the hub. But in some scenarios, maybe you don't even need a token. You could basically connect to your hub anyone, any user without his credentials, and just send the data to him without providing authentication. It always depends on your domain,
on your scenarios that you have. Yeah.
Okay.
In this case, it was cool. But...
So I think that was pretty much it. And the last part is something about these helper methods, right? Because I think in the last episode, when we were talking about console and Fabio and all the HTTP clients, you could see that, for example, within our Fabio client or within our console HTTP client, we were using, sorry, not this one, Fabio client, this one, or this one. We use the poly for the retries, right? For example, here, we have this policy for retry. So if my gateway or my internal service, for example, A, calls the service B, tries to get the data, and it doesn't respond because maybe it's temporarily offline, it will do a retry, and maybe after 3 retries, it will return to me the data is not available. But if within this 2 or 4 or 8 seconds the service will be up and running again, it will get the data within the 3rd retry, right? Yeah. So we use the poly for this, and we have the same stuff for our event handlers and our message handlers in general.
Maybe you can you go to the Poly's GitHub? Maybe we could
okay.
Yeah, because maybe not everyone is familiar with this library. It's very cool for adding the resiliency for your app. I think that's now part of the .NET Foundation. I'm not quite sure.
Some of the libraries use Poly.
Yeah. So if you go down, you'll see that this is this project, and you have plenty different policies that you can actually choose from. So you have the timeout, cache. There is the circuit breaker, retries, and so you can actually adjust your policy. So I would say it's kind of action for dealing with failure, depending on the situation. So you can use, let's say, retries for synchronous communication, or circuit breaker for the synchronous communication if something is if some services are down. And as you see, this is pretty easy to use. So we have this Fluent API where you can define your policy and just as you see, you can see that if we have this exception, we want to kind of deal with this. using this policy. Yeah, so basically this is the library. And as Piotr said, this is the poly was plugged into few places in the common package. So the one thing that you saw already, we've already seen was the Fabio. When we wrapped the HTTP synchronous connection, and this is also in the past subscriber.
Yeah, we have also this. We also use poly here, as you can see. If something, so the idea behind our message handler is that if we get this DShop exception or something else that we treat as our domain or business logic exception, then we know that, okay, you violated some invariants. Maybe you provided the invalid customer ID. Maybe you provided the discount code, which is not unique, or something that will never succeed, no matter how many tries you will retry, this operation. So if it's some business logic exception, domain exception, we know that, okay, so your comment, your event will fail. All right, so we don't care about this one. If this is this DShop exception, we'll just publish this rejected event right away. But if this is some other exception type, maybe your database is currently offline or another service is offline for these few seconds. So if it's some maybe HTTP client exception or whatever it is, which is not related to the domain or some Stack Overflow exception, we'll try to retry the operation within our message handler simply by using poly here as well. And one thing to mention here is that with RabbitMQ and other message buses, there is this concept of dead letter queue and poison queue and poison messages. So in some scenarios, you could, and you can also do it with raw rabbit. When there is something wrong with your message, you can publish it to the queue with this header, which tells, okay, this is a retry, let's say a first retry, and I want to retry in 10 seconds. And you can use your message bus queue to handle the retries. And maybe if after 5 retries, it can be handled successfully, then you can publish your message, which is poisoned or broken somehow, to this dead letter queue. And in this dead letter queue, you get all of these messages that couldn't be processed, right? So you can grab them one by one and process them because there was something wrong with them. But once you have multiple instances of the same services and you are sharing the same queue names, so the only one instance gets the message to process, right? Which is what you want to do. And this is also the question that a lot of people ask: how is it happening? It's happening by default, right? And right now, if I'm using the same queue name for my n instances of the same service type, and if I will publish this poison message to some retry message queue, which turns out to be common for all of the instances, then all of the instances will try to somehow retry the message. So you have to be careful with this with putting these poison messages to the queues. You have to be aware. We have to be certain that you really have this unique queue name so that other services will not get this message. If you are using some routing keys and you are using this hash or star wildcards within your RabbitMQ keys, you really have to take that into consideration because it gets a little bit tricky here. So just to make it simple, we decided to use an internal poly retry. And final thing, how you can use it. So let's get into our discount service. Yeah. And here in the startup, you can define, as you can see, we have a few more things there, and I can just type on error. For example, for our K discount. So I will say on error. And here, if I take a look at this one, it will give me the comment or the message. It will be a comment in this scenario. the comment and the exception that happened, and it expects me to return the new rejected event. So I could say, in this scenario, I want to return a new create discount rejected, and I can pass here my comment customer ID, and my exception may be message, and then some customer not found status code, right? And then I could get back to my handler, not this one, and I could omit this point here. And then the customer could be null, right? And there will be a null reference exception, and there will be retry number 1, 2, 3, and finally we could get this event. The customer wasn't found because something happened. And of course, you can extend this. On error and this retries to
Or
be
you could
something more
simply throw the
sophisticated.
DShop exception instead.
Yeah, right. Oh, yeah. Also makes
because
sense.
that would be makes more sense because in this case
True.
we would not retry.
Oh, yeah, correct. Yeah, it will be a business logic. That makes sense. So
Yeah.
here I could just throw a new DShop exception with this code, which is this one, and maybe our message.
Yeah.
And the message is first one. And yeah.
So that's pretty much up to you. Which version do you prefer? Because for this is just some sort of
enhancement.
Some syntactic sugar.
Yeah.
Or a wrapper onto wrapper. But if you prefer, defining your messages, publishing explicitly in a command handler or the event handler itself, this is fine. If you like to keep everything in some sort of fluent API, then you can just use this another overload of the publish command or the subscribe to command or event as presented. So this is pretty much up to you. Which version do you prefer?
This is just a helper method, so you don't have to just publish these events here on your own. You could just throw an exception and maybe return from this handler in some wrong way, some failed scenario, and it will just publish this rejected event for you. So you don't have to do any try catch in here. It will be just handled by the layer above. And yeah, that's pretty much it for this episode. We discussed pretty much everything related to handling our request, tracking them in real time. We talked about the collation context, what it is, and how we can use the SignalR to publish these operation updates in real time to the end user. And yeah, that's pretty much it.
Yeah, so I would say that for with this episode, you should know how actually to start your journey with the microservices and how this actually should look like, more or less, of course. So how can you fetch data? How can you write to your microservice? How can you exchange messages between them? And the future episodes, maybe except the next one, will be just, or maybe not just, but will be some additions that will make your development and your microservices even more resilient, available, easier to track, easier to I would say develop and debug. Yeah, so I would say that this is the core of the architecture that actually allows you to start the whole fun.
Yeah, and starting with the next episode, we'll get into some of the more advanced topics and also some tooling related to services. But as Darek said, for now you should have the basic understanding. Right now, you should know how to match these messages one with another through this collation ID, and by using this context, you know how to get your services where they live using service discovery, using console and Fabio. So you could start building your first solutions with this architecture.
Yeah. So I think that's it for now, and
Yeah.
we'll see you next week.
Yeah. See you next time.
Yeah. Bye.